All right, today we're going to talk about something huge, a really fundamental shift that's happening deep inside the technology we use every single day. It's a revolution, not just in what our devices can do, but in how the very blueprints of our digital world are being created and shared.
Seriously, just think about that for a second. What if the core instructions, the language that powers everything from your car to the cloud, from your phone to a satellite in orbit, was completely open for anyone to use, to improve, and to build on? You see, for most of computing history, these blueprints have been kept under lock and key. They've been proprietary, expensive, and controlled by just a few companies. But a movement that started in a university classroom is now totally flipping the script.
Okay, so to really get what's going on here, we need to talk about the secret language that every single computer processor speaks. It's the most basic connection between our software and the hardware it runs on, and a new, open version of that language is taking the world by storm.
So this language has a technical name, an instruction set architecture, or ISA for short. But the best way to think about it is like a recipe book for a chip. It tells the processor exactly what it can do and how to do it. And for a long time, just a handful of big companies owned all the best recipe books. Well, RISC V is a brand new one, and it's open source for everybody.
So where did this totally game-changing idea even come from? Well, it didn't start in some slick corporate boardroom. Nope. It began as a pretty straightforward academic project with, surprisingly modest goals.
Just look at how fast this thing exploded. It starts in 2010 as a simple project at Berkeley. Then in 2014, this one paper just ignites the industry. By 2015, they hold a workshop. They're probably expecting a few dozen academics. And suddenly 40 companies show up. Fast forward to 2020, and it's a full-blown global standard based in Switzerland. I mean, talk about going from 0 to 60.
This is the paper that really changed everything. It completely reframed the conversation. All of a sudden, RISC V wasn't just some interesting open-source hardware project. It was positioned as a piece of fundamental digital infrastructure, as vital and as necessary as the open standards that run the internet.
And what's so wild is that, at first, as this quote points out, academia wasn't really that interested. They just wanted to teach students about the chips that big companies were already using. It was the industry, the people out there actually building things, who saw the massive potential and created this pull that forced everyone else to pay attention.
Okay, so you've got all this crazy momentum, right? But that brings up a huge problem. How do you stop a great idea from splintering into 1,000 different incompatible versions? Well, you build a rock-solid, global standard that everyone can trust and build on. You see, for an ecosystem like this to actually work, it needs stability. It needs predictability. A software developer has to know that if they write code for RISC V, it's going to run on a whole range of different hardware from different companies. No weird surprises.
And that is exactly where RVA23 comes in. It's a common baseline, a standard profile for the kinds of processors that run big-time operating systems like Linux. It creates one clear target so that all that complex software can just work right out of the box. This is the key, the thing that unlocks the door to huge, complex markets like cars, AI, and data centers.
And believe me, the impact of that stability, it's projected to be absolutely massive. According to analysis from SHD Group, RISC V is on track to capture over a third of the entire market by 2031. Just let that sink in for a moment. From a classroom project to a third of the industry in just about 2 decades. And this chart really shows you what we're talking about. We are not talking about slow and steady growth here. This is a projected jump of more than 10 times in just a decade. It's an exponential curve, and it's being driven by real adoption in the most important industries in the world.
So this isn't just some abstract tech story happening in a lab somewhere. This stuff is already having a real, tangible impact on the world all around you. So let's take a look at where you can actually find RISC V, both today and tomorrow. First up, your car. Not long ago, Infineon, a global giant in automotive chips, announced their entire future roadmap for microcontrollers will be built on RISC V. I mean, that is a huge vote of confidence from an industry where you absolutely cannot mess around with safety and reliability.
So why is this happening? Well, the whole architecture of cars is changing. We're moving from having dozens and dozens of little separate electronic brains to these smarter, consolidated zonal controllers. And RISC V is perfect for this because its flexible design can be used for everything from simple window controls to the complex central computers.
From the car, we go to the cloud. The massive data centers that power pretty much our entire digital lives, well, they demand standardization and efficiency above all else. And with these new standards in place, RISC-V is now a totally credible, really powerful option for building the next generation of servers.
Okay, now let's go from the cloud to probably the most extreme environment you can possibly imagine. This quote really sets the stage. Space is just an incredibly hostile place for electronics. So what kind of processor would you trust for a mission-critical satellite?
Turns out, the answer is increasingly RISC-V. That's right, both NASA and the European Space Agency are adopting it. And why are they picking it? Because it's open, which means they can build completely custom, radiation-hardened chips that are perfect for the brutal conditions of space.
And then, of course, there's the one technology that's touching everything right now, AI. The thing about RISC-V is it wasn't just adapted for AI, it was pretty much designed for it from the get-go. It can handle simple control jobs and the super heavy-duty math needed for AI, all on the same core. That's a massive advantage. And the result, as the source material says, almost every new AI accelerator project is using RISC-V.
So when you step back and you look at the whole picture, you see the explosive growth, you see the adoption in these absolutely critical industries. It becomes so clear that RISC-V isn't just another chip technology. It's something much, much bigger.
What we're seeing here is way more than just a new kind of chip. It's a fundamental, structural shift in how we build technology itself. We're moving from a world of closed-off, proprietary designs to a shared, collaborative model for building the hardware that runs our world.
You know, there's a really powerful parallel here. A few decades ago, Linux proved that a global open community could build a world-class operating system that could compete with anyone. Well, now RISC-V is proving that that exact same model can work for the silicon itself, for the hardware.
And this brings us right back to the beginning, to the biggest, most exciting question of all. The fundamental recipe book for computing is now open source. The gates have been thrown wide open. So the only real question left is, what incredible new things are we going to build with it?